Hello everybody. So today we will be entering chapter 10, which is on the wave properties of light. So this is a very short chapter. So as I mentioned in class, we will be combining this with chapter 11 lah. But the lecture videos will be separate. It's just that we will discuss these two chapters this week lah. Okay. So the first subtopic is on the Broglie wavelength. I don't know how to pronounce that. If you want to pronounce it in the correct way, just Google it. So in this subtopic, you have to be able to state the wave-particle duality, and then use the Broglie wavelength equation, which is this one. Okay. So what is this Broglie wavelength? So we know that the Planck's quantum theory energy of a photon can be calculated using this equation here. Okay, so and then we know that from the Einstein special theory of relativity, the energy of a photon pula is given by this equation here. Ataupun yang ini. Okay, so if we equate these two equations together, we can then get so we can then get this equation here, which is shown here. Okay, so from here we can actually see that the duality of a wave particle lah. Okay, so the momentum is the particle aspect of the wave, and then the wavelength is the wave aspect lah. Okay, so P is momentum lah. Kalau kamu ingat, our first sum chapter 3 is on momentum. Okay, so and then we know that the momentum equation, from the momentum equation, thus we know that light has momentum and exhibits particle theory. Okay, so from that we can say that light is dualistic in nature. Okay, so they are dualistic in nature, so they are behaving in some situations like wave, and then in others like particle ataupun photon. Okay, so this phenomenon is what we call wave particle duality of light. Okay, so this table here pula, it is showing the experiment evidence in which it shows that the that the light do have duality, wave particle duality. Okay, so the experiments yang tunjuk light is a wave is the Young's double slit experiment as well as the diffraction experiment, and then untuk particle pula photoelectric effect ataupun Compton effect. Okay, so based on the wave-particle duality of light, Louis de Broglie suggested that matter, such as electron and proton, might also have a dual nature. Okay, so he proposed that for any particle with momentum P should have a wavelength of lambda, and that is given by this equation here. Okay, so apa yang change is just that P is gonna be equal to mv lah dari sini. Okay, so this is the de Broglie relation. Alright, so m is the mass of a particle, v is the velocity, h is Planck constant lah. Okay, so this wave properties of matter is known as the de Broglie waves ataupun matter waves. Okay, and then another scientist, Davison and Germer, succeeds in diffracting electron, which they are able to show that electrons do have wave properties. Okay, right. I think, so that is the first subtopic. So the one that will be in PSPM is this first subtopic lah. I think the second subtopic, ada juga. Okay, yeah, so the one in PSPM is gonna be about calculation. Okay, so that is on our first subtopic. I'm sorry it's moving. It's my cat punya paw on this iPad. Alright.